Okay, hi everyone. In this lecture, we are going to talk about the interceptor design pattern, which we are used with server-side web programming when we are using Java as a programming language, right? Up to now, this is the architecture of our web applications, right? Let's say you are going to develop your website using servlets, right? Then in this side. In this side, we have one or more clients, right? Then clients make some requests from web servers. Let's say this is the web server side, right? This is the server. Clients can make some requests from the server through the internet, right? The internet could be anything, any medium we can use as the uh, internet, right? In this server side, we have some set of databases which are connected with the server, or in other words, the required data values of our system will be available inside this database, right? These databases will be connected through a database management system to our server, right? This is the server side. Then we have set of servlets for login, sign in, sign up, right? And then register, and many more servlets could be available. It's depending the number of servlets and type of servlets will be depending on the system requirements, right? We can't say this is the fixed number of servlets that are available in your system. We can't say, right? Uh, the number of servlets and the type of servlets will be, and the number of do methods and get methods, or all the things will be depending on the system requirements, right? Then these servlets can access to these databases to a database management system, right? Then they can communicate with each other and get required data from database, right? This is the uh, server side, right? Then if you are using a servlet architecture, there's a specific file called web.xml file. It is at the front of this architecture. Then clients can make some requests to the server. This request first, this request go to the web.xml file, right? Then web.xml file will be redirect your request to the appropriate server. If you are using the MVC architecture, there's one more layer available here. We call it as dispatcher servlet. Then this web.xml file directly forward your request, all the request to the dispatcher servlet, and dispatcher servlet will be selected what is the most suitable servlet from your system, and uh, send your request, forward your request to that servlet, right? Then there is another, when we using an MVC architecture, we have model view controller. Then we have a separate section for viewing, view your data, or presenting your data to the client side. Then finally come up with the view name and the data model. The controller will be, or the dispatcher service will be send your respond. Actually, now it is respond to the view section, and using the templates available in the view section, we can place the model data on that places and send it back to the client side. That is the complete cycle of a MVC architecture or a servlet architecture, right? Then this servlet can, sorry, web.xml file can send or forward your request to the appropriate server, right? But in the physical sessions as well, uh, I told you we have to, let's say your system has a login register and login systems, right? Then a new user should create a account on your system before accessing to the or before getting all the privileges from your system, the new users should register in your system. Once they register, after that they are going to access to your system again another day, or after first log out, then again you're going to access to your system again, right? Then you have to validate this user is already available in your system or not, as well as you have to check the entered password is similar or matching with the password stored in your system, right? In previous cases, we are applying all the this authentication process, authentication filters inside the servlets, right? Inside the servlet, it's in login servlet. We are applying the authentication inside up as well. And in register, we have to check the IP address as well, right? Is it a valid IP address, and all the things we have to check before accept a request from client side, right? Otherwise, some requests can hack our system and get access to the third party hackers, right? Therefore, before get into the request from client side, we have to filter. We have to check, uh, or we have to clarify this request is valid or harmful, not harmful request from the client side, which is coming from the client side, right? Then before get into this request, we have to check, we have to filter this request from a specific layer. We call it as filters, right? We are applying a specific layer, applying a specific filter layer to filter out all the requests before get into our main logic, or get into our main part of our system, right? Actually, we are applying a barrier here. We are applying a barrier here, right? Then only the approved request will be get into our main system, right? Then using this method, we can protect our main system or main business logic, right? To add a filter, we can do in traditional way, we can use nested if structures, right? If conditions, if and else condition, we can add some these things. Uh, Right, before getting to all the requests to our main system, we have to examine six conditions, right? We have to check six conditions. Let's see, what are those conditions? We have to check whether, uh, check before getting to all the requests to our main system. First one is, has the client been authenticated? Has the client been authenticated? Right? The first thing we have to do is, first we have to check the incoming request from the client side is a registered one or authenticated one, no illegal one, right? This is the first one. At the second step, we have to check, does the client have a valid session? We talk about the session in HTTP session management as well. Does the client uh, have a valid session? Sometimes this session could be expired, right? I told you in the session management, we are adding a expire or the valid time period to a session or a cookie as well, right? We have to check this session, the session available in the request is valid or not. Then the As the third step, we have to check is the client's IP address from a trusted network. Client's IP address uh, from a trusted network, right? This is the third one. Fourth one, does the request path violate any constraints? We can add some constraint for the system or some security policies, right? Then at the fourth one, we can check this upcoming request is violate our security constraints or not, right? Does the uh, request path violate any constraints or security policies, right? And as the fifth one, uh, what encoding does the client use to send the data, right? As a commercial application, we are not exposing all the information in the plain text as the plain text, right? We are at some encoding method, mainly for the password, right? In our system as well, let's say we are applying 1234 as the password. It is not stored inside the commercial application in the form of 1234. It will be encoded to a different set of characters. Then we need an encryption key and the decryption key as well to encrypt and decrypt process. We have already discussed about the encryption and decryption as well, right? Then as the fifth step, we have to check whether the encoding method is a valid one or not. What encoding does the client use to send data, right? And the final one, uh, we have to check our system is support with the browser type of the client, right? Sometimes our application not be suitable for the specific browser, right? I told you at the very first or second lecture, the interfaces will be depending on the browser we are using, right? Then we have, as a developer, as the front-end developer, we have to consider all the browsers and their requirements, right? Then before sending our request to the client side, so the response to the client side, we have to check our system. To our system support the type of support be the type of client browser, right? This is very important, right? Uh, if any of this any of this condition is not satisfied with the upcoming request, we have to send a proper error message to the client side, right? One of this point is violated. If upcoming request from the client side, we have to send a proper uh, proper error message to the client side without get into our main system, main part of our system, right? Therefore, we have to carefully, uh, we have to apply a security barrier in between the client and the main web content of our server side, from our server side, right? To add these filters, we can use one thing is we can use a nested if condition if, or switch case conditions. But it is not sufficient for a large scale application, right? Because there are so many requests are coming from the client side to our server side as a commercial application, then we have to think about the another way to do this task, right? And for this one, we can use interceptor design pattern. We can use interceptor design pattern to add some filters in between client and the our main system, main server-side system, right? We are using interceptor design pattern to implement the security filters, security barrier for our system, right? When we think about the interceptor pattern, this interceptor pattern can use for authentication process, access validation, system login, system debugging, then data encoding, browser trapping, and response filtering. We are covering all of these requirements, right? Using this interceptor pattern, we can come up with a solution for answer for these 6 questions, right? Using this interceptor pattern, we can answer all of these 6 questions. If all the 6 questions will give yes condition, yes, this is safe. The this client is authorized, authenticated person. The session is valid. The IP address is trust, right? Then the this request is not violated with our system policies, right? Then the encoding algorithm is also valid for system, and this request is or the browser type of the client is support with our system, then we'll, if this sixth condition will give yes condition, we can allow this request to enter our main system, right? For this purpose, we can use interceptor design pattern. There are other design patterns as well. We can use to replace interceptor design pattern, chain of responsibility, decorator pattern, and front controller pattern, right? But the difference between these 3 patterns are with the interceptor pattern. The interceptor pattern uh, will we can customize, right? We can add some our requirements to this pattern. But in other 3 patterns, these are built in, already built in. We cannot customize those things, right? Then we call interceptor filter patterns are pluggable. In other words, we can apply this one uh, from this system to another system. Let's say we are going to build a separate system later on, we can apply the entire filter, develop filter for the another system, right? Without any conflict. We sometimes we can make some, we have to make some changes to the previous one, but we can simply add these filters to the new one without any doubt, right? That is the main advantage of using interceptor design pattern. Right, when we see the UML diagram of this system, okay, if we see the interceptor pattern, UML class diagram for the interceptor pattern, this is the client, right? Then this is target. This is target servlet from our system. Let's say the client is accessing for the registration page of our system. This will be the target. Registration page will be the target of this class diagram. In between client and target, we have a filter manager. Filter manager. The filter manager is connected with the filter chain. Then we can add the required filters for this one, right? These filters will be independent from each other. This filter is will don't know about this one. This filter 2 is don't know about the filter 3, and filter 3 is don't know about the filter 1. What are the available conditions? What are the available things in these filters? These filters are independent from each other. These filters will be connected with the filter chain. This filter chain is connected with the filter manager. Once you make a request from our server, then your request first go to the filter manager, then filter manager is forward your request to the filter chain, right? Then filter chain will apply your request to all of these filters and get the response. If the all filters will be giving uh, a good response or the yes response, right? Your request again will be forward to the filter manager, and filter manager forward your request to the target resource from your system, right? This is the UML diagram, UML class diagram for a interceptor pattern, right? Then this is the UML sequence diagram, right? First, client will make a request, then a request go to the filter manager, then filter manager forward your request to the filter chain, then filter chain will apply your request to the each and every filter, filter 1, filter 2, and filter 3, and process inside the filters, process inside the filter and get a forward a feedback from filter chain to the filter manager. After that, the filter manager, finally all the requests are good, all the responses are good, all the feedbacks are good, then file manager will be forward your request to the target. Then your request will be processed inside the target and send it back to the client side, the relevant with the relevant data and model, right? This is the complete path or the UML class, sequence diagram of the interceptor design pattern, right? This is the thing. These are the theory parts behind the interceptor design pattern, right? Let's go to an example, right? Before going to the web application, I will explain uh, interceptor design pattern with a simple Java program as we did in the MVC design pattern as well. First, I will explain about this interceptor design pattern using a Java, simple Java application. After that, I will give you an exam assignment, right? I will give you an assignment to based on this interceptor design pattern. Then you have to do it within a week and submit your answers. After that, we can discuss this question in our physical sessions, right? Okay. Okay. I will show you an example. In this case, I'm going to build a program. So before going to that one, uh, just summarize the content, summarize the interceptor pattern. What is the reason we are adding interceptor pattern? The purpose of adding interceptor filter design pattern to our system is adding a security layer to our system before getting the request from the client side to the main system, right? Before adding, before getting all the requests from client side to server side, we are checking these questions. We are checking the request based on these questions, right? Has the client been authenticated? Does the client have a valid session? Is the client's IP address from a trusted network? Does the request path violate any constraints? What encoding does the client to send the data? Do our system support with the type of client's browser, right? We have to examine based on these 6 questions, right? Then if all these questions will give yes or positive feedback, then yeah, all the requests will be get into our main system, right? Then what are the main characters of interceptor design pattern? First, we have filters, right? Then we have filter chain, then filter manager, then target, and finally the client. These are the 6 roles involved with Interceptor design pattern, right? What are the filters? Filters mean filter which will perform certain tasks prior or after execution of request by request handler, right? Before entering or before allow to a request to enter our system, we are perform some task, right? What are the filter chains? Filter chains carries multiple filters, right? The filter chain will be connected with all the filters individually. Filters are not connected from each other, right? As we see in this one, you can see filters are not connected to each other, but these filters are connected to the filter chain, right? Then filter manager manages the filters and filter chain, right? Then target will be the object is the request handler. It could be a servlet, right? It could be any other uh, main component from your system. It is not a case, right? Target will be the target resource, target object of your system. Then the client is the person who makes request to the target object, right? These are the main roles that are in uh, uh, those are the main roles with involved with interceptor design pattern, right? Okay, then let me see how we can implement interceptor design pattern with a simple Java application, right? First of all, we have to create a filter interface, right? The purpose of this interface is we can implement a method, abstract method, right? This is an interface. Then we have to add only abstract method, right? Then after that we can implement this filter from our actual filter classes. Then we can override this method, right? In this case, I have created a method called execute, and it will take the request as a string parameter, right? After that, I can create a set of filters. Authentication filter, for an example, or authentication filter. This authentication filter class will implement this filter interface, right? Then I here I have override this execute method with this console message, right? Or the authentication request, then request will be print on the console area, right? The purpose of this one is check the behavior when we are passing a request to this pattern, how it's behaved, right? We are going to check how it's behaved, right? What are the parts what are the classes this request is accessing, right? This is the purpose of this application, this example, right? First, we are applying or create implement an interface, right? Interface has a method called execute, right? Then authentication filter is a simple class and it implements filter. Then we can override the execute method with the console message. In real world application, in real world case, we can apply the required authentication conditions here, right? For the second one, debug filter. Again, debug filter is a simple class and it implements with the filter. And here I have override the previous execute method with this console request, console message, right? Then I have here created a target, right? In target, actually in real world case, real world scenario, the target will be a servlet or any other web content, right? In this case, just I'm creating a console message executing request. Executing a request means in real world case, we are processing the client request, right? Right. Then these are the filters available in my system, authentication filter and debug filter. This is the target, right? Then this filter is is an interface, right? Then we have to create a filter chain. Then filter chain will connect all these filters, right? This is the filter chain. This filter chain will connect all of these filters, right? Therefore, first of all, I have created a list here. The list type is filter. This list can hold all the objects that are created based on this interface, right? That is the purpose, right? If otherwise, we cannot store all the filters uh, inside this type of list, right? Because this object is authentication filter type. This object is in debug filter type, right? But in this case, this is a superclass of both of these. Then we can create a type of this filter list as filter, right? Then we can store all the objects which are having a superclass as filter, right? This is an array list. Then here filter chain should connect with the target as well, because this filter chain is connect with the target through the file manager. Then here I have created an object from target, right? Object from target. Then we can store this target inside this variable. Then there should be a method to add the filters to this system, this list. Therefore, I have created here a method add filter. Then this will take a filter interface type object as the parameter. Then we can add this filter to this filters list. Then there should be a method to execute the filters, right? Once you get a request to this filter chain, then you have to execute this filter classes of set of filters one by one to the request, right? Therefore, here I have created enhance for loop and get filter one by one and pass request. Get filters from this filters list one by one and apply this request. Apply means execute these filters, right? Execute these filters on top of the request, right? Finally, if this all request all filters are given positive feedback, then we can finally execute the request with the target, right? The execute method. The purpose of this execute method is execute all the filters based on the request, and finally all the filters will give positive feedback. Then we can execute target on top of the request, right? All right. Then here I have created a simple method to add target, right? Add target in this, or you can use this filter chain object as well. Here simply I have created a set target object as set target method here. This is not mandatory, right? Okay, then next we have to create filter manager, right? Because in here filters are created, filter chain is created, and target is created. Then we have to create a filter manager here. This is the filter manager. This filter manager will manages all the filters available in our system, right? Then therefore, this has an object of filter chain, object of filter chain class, right? Then using the constructor of this class, we can add a set of filters to the filter manager as well as the target, right? We can add using the constructor, we can add set of filters and the target to the filter manager, right? The purpose of this constructor is that, right? Then set filter and filter request, right? We can use set filter to set up filter or add filters to the filter chain, and we can use this method to execute filter chain or set of filters available in the filter chain object, right? Then finally, we have to create the client. Actually, in this case, we are simulating, right? We are simulating an actual web application with a simple Java program. This all the classes that are represented here, these are represented these roles, right? These roles: client, file manager, file filter chain, filter one, then set of filters, and the target, right? We are simulating the process. Then this is the client side. Client is connected with the filter manager, therefore created an object of the type of filter manager. Then this method is used to set the filter manager for this object, and this method, the purpose of this method is execute or request the filters from filter manager, right? We have to pass the request as the parameter for this one, and this method will request the filters from filter manager, right? Filter manager dot filter request, right? Finally, we have to create a main method, or we call it as the demonstration, right? I have created a demo class here. First, we have to create a filter manager or initialize the filter manager with a target object, right? Because of this passing this target object is here filter manager is taking a parameter, right? A parameter target type parameter. Therefore, here I have created an object and passed here. Then filter manager dot set filter. Here, using these both code lines, we are adding filters, right? Here, filter manager is available. Then we are adding two filters: authentication filter and debugging filter, right? These objects are created from these two classes. Then we can pass these filters to the filter manager. Then initialize a client here. It's an object. Then client can or we have to set filters, or we have to set filter manager. If we set filter manager to the client, it's automatically adding all the filters to the client because or through this filter manager, because we have already added these objects, authentication filter and debug filter, to the filter manager. Therefore, we are adding all the filters through a filter manager to the client object, right? Here we are adding all the filters through the filter manager to the client object, right? Then we have to execute our program. Then we can say send request, right? Let's say you are going to request this login page. We can simulate it by passing as a string here, right? /login. We are targeting, or we are going to access to the login page of our system. Then we can say client.send request, right? This is the basic simulation of the system, right? Interceptor design pattern. Then let's see what happened when I run this one as a Java application. See, this is the output which I have getting here, right? Once you send the request, right, all the our request will be passed through all these authentication or filters, right? These two filters are not connected to each other, right? These two filters are not connected to each other, but this login request is accessing all of these filters that are available in our system. In this case, we have two filters. Therefore, this message on the console, what is the meaning? We are accessing this one, right? Again, we are accessing this one, request the block. This is coming, this console message is coming from this one, right? We are accessing this one, this class as well. Finally, we are executing the request, login request, right? Okay, this is the life cycle, or this is the pathway of interceptor design pattern, right? This is very simple, not too much complicated. I will share this code with you through the LMS, then you can go through this one, and I will share uh, an assignment with you, individual assignment with you. Then you have to do it within a week and submit. Then we can discuss it with in our physical sessions as well, right? Okay, this is the very simple simulation, not an actual web application. This is a simulation. We are simulation to demonstrate about the interceptor design pattern, right? I hope you get an idea about the interceptor design pattern. What is the purpose of design using this interceptor pattern of our system, in our system? I hope you got something. Okay, then let's see in the next lecture.